Okay, I think we are ready to go. This is ETC Core Devs Call number 14. And the agenda is published on the ECIP's repository issue 362. And this time I also published HackMD. Let me just post this on Discord. I will use this to visualize some things we are talking about today. And if you're just if you're interested to follow, you can just have it open. On the bottom, there will be a matrix, which will be later useful for evaluating and comparing some of the proposals we are discussing today. We have two blocks we are talking about. The first is the last call proposals, which today is only 1099 calibrate epoch duration. In this block, we mainly have to discuss the activation schedule. We will not discuss the Keccak proposal. There is apparently more need to discuss this further, so there will be another call at the same time next week, just discussing this one proposal. This is 1049. So today we will focus on 1099 and the other 51% proposals. I will bundle the 51% proposals because they all serve one purpose, and they might conflict in implementation. Some might also work together, but we need to eventually decide to one or multiple. But we somehow need to start condensing that list towards a set of proposals that we actually want to work on. And that is the proposals 1092, 1094, 96, 97, and 1100. Is there anything missing? Is there anything we should talk about today? I don't think so, but speak up now if you want to add anything to the agenda. I think it's a fully packed agenda for the next 90 minutes. But let me know if there's anything obvious missing.
One thing, I don't think the guys from Veriblock are going to be here. Do you think we should remove that item from the agenda or just continue? Because they haven't done their presentation also. Just trying to keep everything, fair.
Yeah, I mean, we are kind of running out of time. And so today I want to, at least if you scroll down on this HackMD, yes, you see there, I want to build this matrix of attributes for each proposal. And if there's no one here, if Max is not here or anyone else from Veriblock who can answer this question, then we need to kind of try to at least crowdsource these points. So at least we get a feeling if we will work towards Veriblock activation on Ethereum Classic or not. So let's keep all of these proposals on the agenda, and I mean maybe it crystallizes out that we favor another one anyway. So let's see how it works out.
Yeah, sounds good.
Can we do a roll call and see if anyone's here to represent any of the proposals?
Yes. So this is the second block of this call. So I want to start with the immediate hard fork that we scheduled 2 weeks ago. Beso team and also Bob said this is way too fast. We cannot activate at least for Beso in this given time. So we had to push back the block numbers. Maybe we can do a quick Teams check-in. Is anyone here representing Beso? I see Bob is here, so at least we have someone following the Beso development process. Is anyone here?
Yes, I'm here.
Okay, thank you, Bob. Anyone representing CoreGas? It's probably Isaac. I don't know if you're muted. I cannot hear you.
Alright, can you?
Oh yes, I can hear you now. Is anyone representing any other client that's not? Okay,
Yeah.
so
Brian from IOHK here representing Mantis client.
hi. Welcome to the call. Okay, so for the uninitiated, the ECIP-1049 calibrate epoch duration, this is basically a modification of ECIP to cut the epoch number in half, which will subsequently reduce the DAG size, but also DAG growth rate significantly. We kind of call this etc hash, and this will require a hard fork, so clients need to implement it. But it will also require custom tooling. It will be requiring updated mining software for miners. It will require mining pool software updates for mining pools. And to coordinate this, we used to have we scheduled activation for Mordor Classic Test Network 3 days ago. Obviously, we did not make it. The code in CoreGas is prepared as far as I know, but Besu still needs more time, and so we decided to move this back, and we kind of missed the chance to activate this before we reach the 4 GB limit for 4 GB GPUs. This is kind of unfortunate, but it's still not a big deal, I believe, because we still can enable it within the next 8 weeks. And I have added this to the call agenda, to the call thread on GitHub, proposing block number 11,700,000, which is Epoch 390 on the Ethereum Classic main network, which is basically in 8 weeks. And I hope this is enough time for mainnet activation, and I provided a block number for the Mordor Classic network, which is block 2,520,000, which is on the epoch boundary of epoch 82, which should happen in around 4 weeks. And I hope that all clients can make that, so we can test this on Mordor first. Does anyone have any comments on this proposed timeline, or does anyone have another proposal?
So I'm still waiting on confirmation from ChainSafe in terms of availability and so on, but I think that timeline is doable. Yeah.
Okay, so shall we add these numbers to the ECIP?
Yes, I'd say.
Okay, so we could, for start activating, or maybe we start working towards the CoreGas release with these block numbers, and we can see that that Besu makes it into the next RC release cycle, if possible, so we can test Mordor hard fork in 4 weeks.
Yes, that would be the goal.
So if I understand correctly, you're saying 4 weeks for Mordor activation, 8 weeks for mainnet activation?
Exactly. This depends a little bit on block time variations. Mordor has a very low hash rate, and also mainnet has varying hash rates right now, but more or less 4 weeks for Mordor, 8 weeks for mainnet. Putting us at end of October or end of November.
Do we have any sentiment from our major mining pools? I'm pretty sure it'll be easy to get, but if anyone already has any direct answers from them. Like, I would assume it's enough time, but unless anyone has information there.
Yeah,
Right.
because this includes the mining software and all that as well.
So I know that the ETC core team is not only working on the CoreGuess client implementation of the ETC hash upgrade, but also working on a reference implementation for the ETH miner C++ mining software, and also for the Open Ethereum mining pool. I don't know if Luke is on this call. He could answer that, but so at least we would have everything ready in time, and other proprietary pools or miners would have to adapt at this point. But I mean, the changes are fairly, they're not simple, but they are limited in scope and complexity.
What was the name of the second miner software?
There's this open source Ethereum mining pool software called Open Ethereum Pool.
Thanks.
Okay, if nobody vetoes this, I would propose that we add these block numbers to the ECIP and start encourage the clients to start working towards implementation and releases.
Do you know if I don't know if anyone's here working from the ETH miner, but is the ETH miner changes going to be merged in upstream or a fork?
I don't think anyone's here on this call, and also I don't think this can be answered here. Of course, we will always submit changes upstream, and we will then see that if they accept it or not. But I don't see why they should not accept it if we have a proper implementation. But let's move on. This leaves us plenty of time to discuss the 51% attack proposals. I will start with the suggestion that everyone that we just check who's around. Is anyone representing Callisto ECIP-1049 Pirlguard? Or does anyone want to speak on behalf of this proposal? What about Veriblock 1094? That should be Max. Okay. Merged mining 1096.
Yes, Sergio and Martin is also here to answer any questions you may have, or if you want us to explain a little bit about it, we are open.
Thank you. Also, thank you for answering my questions ahead of time. This is really helpful for preparing this call. Anyone able to represent 1097 checkpointing?
Yes, this is Kostis from IOHK.
Perfect. And ECIP 1100 modified exponential subjective scoring.
I'm here. I'm Isaac.
Okay. Okay, what I'm going to do is, before we go into the discussion, I want to just give a short, too long didn't read, a one-line summary of each of the proposals. Then I'm going to ask 6 questions, and if you have this HackMD open that I posted on GitHub and Discord, then I will try to fill in the gaps in this matrix, and we can start discussing afterwards. Does this sound like a strategy for this call?
Sounds good to me.
Okay, so let me quickly explain Pirlguard, which was implemented and activated by the Callisto community. It is a 51% attack mitigation that requires attackers to mine penalty blocks before allowing privately mined chains to be accepted as main chains. This kind of increases the work required to actually attack the chain, and therefore increases attack costs. The Veriblock proposal comes with the so-called proof of proof concept. So instead, in addition to proof of work miners, you have proof of proof miners that endorse the ETC blocks publicly on the Veriblock chain, which in itself inherits security from Bitcoin. The merged mining proposal is having some kind of visibility proof scoring that allows clients to choose between computing chain heads based on the scoring. It comes with different specification possibilities that can be discussed later. The checkpointing proposal is basically adding some kind of proof of it's like a BFT network layer on top of the proof of work layer of the mainnet, which makes 51% attacks kind of impossible, but it requires a trusted committee. And the MES proposal 1100 applies exponential scoring to blocks unknown to the client, which would significantly increase attack costs based on the length of these attacks. So we don't have anyone here speaking on behalf of Pirlguard. Is this correct?
Yeah, I don't see anybody in the call either.
So I have this matrix. I have 6 questions. It's basically, does this require a hard fork? Does this break Nakamoto consensus? Is there a specification for Ethereum Classic available? Is there a transition for activation specified? Is there any implementation or simulation available? And are test cases available that can be used by client teams? I think this will give us some insight in these proposals. For Pirlguard, I have added, I know, Cody, you have done an implementation in Go. Is this correct?
Yeah, that's correct. I also have an implementation of MES and a couple of the other proposals.
Oh, okay.
No
Do you want to help me just filling in the gaps with the Pirlguard proposal?
Sure. Opening up the document now.
So, if I understand correctly, there's no hard fork coding required to activate Pirlguard. Is that correct?
Correct.
But as with many other of these proposals, some kind of coordination helps to prevent network splits, right? So, like
True.
having like a block, not a fork block, but like activation block.
Right. Yeah, it helps with coordination.
Okay. As far as I understand, it also does not break Nakamoto consensus. Is this correct?
Correct.
Okay. Unfortunately, the specification for Ethereum Classic is not really sufficient. We would need to work on this ECIP, I believe, if we were to implement it. We kind of need to fill in the gaps how to implement Pirlguard in Classic. So far, this ECIP-1049 only links to the Callisto implementation and specification. So I put up a red X here, and I don't know if there are any test cases available. I don't know if you know.
No, not that I'm aware of, no.
Okay. So, Veriblock proposal. Is anyone familiar with the Veriblock proposal? Okay, I will just quickly jump over it because from how I understand it, it modifies, it requires a special opcode, and it requires a block header structure. So this will require a hard fork from how I read the proposal. I can't evaluate on Nakamoto consensus. The specification is very well specified, especially for the Ethereum Classic use case. I didn't see any transition specification, and I'm not aware of any implementation or test cases. But I will just leave the question marks up here unless anyone else has more clear answers on it.
They said they're going to be releasing a document next week, mid next week before their presentation. So if they have that documentation ready by then, that's all I know.
Okay, fine. So we can continue updating this matrix continuously. The merged mining proposal does not require a hard fork. However, it could. So from how I understand it, if you want the full potential of the proposal ECIP-1096, you would want to have a hard fork. Is this correct?
Yes. So the proposal is a second layer security protection, but to get really a decentralized system, the idea is to channel some funds from the subsidy, any amount. It's not important, but if we really want to make this decentralized, then some amount should be channeled to these visibility proof miners to be incentivized to participate. If we do not do that, so we do not make a hard fork, then of course you can pay this group from a treasury or from grants or from other ways of paying, but it would be more centralized. So the good thing is that even if this is something that it's paid off chain, then the group does not have much power. It can only prevent the nodes from being alive, but they cannot reorganize the blockchain. So they are very limited in the actions that this group of limited miners can do. So yes, you can do that without a hard fork, but it loses some of these properties.
Okay, thank you. Does it break Nakamoto consensus? You said no, right?
No, nodes take local decisions based on visibility proofs, and they enter safe modes. And this is a local decision of each node. Sorry.
Okay. So I will update this. It's well specified. You said there's no transition yet, so this can be either smooth or at a hard fork, right?
Since nodes take decisions by themselves, then some nodes could be listening to visibility proofs, and some nodes could not make use of these visibility proofs. Of course, it will be great if all nodes are coordinated, but it could be gradually nodes, economic nodes, such as exchanges could adopt the system, and then the other nodes could also do that.
Okay, and you don't have any implementation and tests yet?
This proposal was made specifically for ETC community, so we do not have a full implementation. We do have the universal merge mining system in RSK, which is a system that helps channeling these proofs to the Bitcoin miners, but not the changes to ETC, right?
Okay, thank you very much. The checkpointing proposal, it basically adds, it basically adds the second layer of consensus, from what I understand. So this will require a hard fork, but correct me if I'm wrong.
Yeah, it actually does not. In the ACIP we focus on the case of the hard fork for the OBFT, but we also mentioned possibility of soft fork is available, and especially we mentioned this in the case of using Bitcoin as a timestamping service. So to correct something that was said earlier, it's also not necessarily centralized. You have the option of it being centralized with an OBFT network of federated nodes, or decentralized by using some other blockchain like Bitcoin. In a similar way, but not in the same way, but in a similar way that perhaps the...
Okay, thank you. So I will just quickly take notes.
I would like to add that there is a possible combination or collaboration between IOHK and our proposal, in the sense that this could be a federation generating, for instance, the visibility proofs. So we could combine a federation with visibility proofs, and there is some benefits in this combination.
Okay. This kind of breaks Nakamoto consensus, because the check. Yes.
Go ahead. Sorry, I would like you to finish first because before I comment.
Okay. The question is, does it break Nakamoto consensus? I believe yes, but happy to comment on that.
Yeah. I think I would like to ask from the beginning is, what does it mean to break Nakamoto consensus? Because the question, it's probably one of the most important questions in this, and to me, it's not clearly necessary. It's not clear what that means in this case. So we have some properties that we want the network to maintain. What are the properties we care about? What does it mean to break Nakamoto consensus in this case?
Sure. Yeah.
Yeah, but because I expect the answer to that to be very long formed and perhaps up to debate, I guess we can move on to the rest, and then we can tackle this also for the rest, because I'm not sure I understand the rationale of the answers for some of the other protocols as well with regards to this.
Yeah, sure. I spent this morning to just come up with questions and this matrix, and we can discuss all of them. I will just open up the discussion in a bit. Let's just go through all the other points, if you don't mind.
Yeah, sure.
Okay. It's fairly well specified, but you also said that there is no. I think we talked about this previously. There's no. There's no transition yet, or like activation plan available, right?
Yeah, we don't. If that means that we have a specified block number at which we expect to activate, that's not the case. But I don't think this is like this criteria is a criteria that can be easily remedied. I don't think it's related to what the proposal is exactly. If that makes sense.
Yeah, sure. And I see you have a pull request up for checkpointing. I believe this will be this one. Correct me if I'm wrong. On the Mantis client.
Yes, on the Mantis client we have an implementation, and perhaps Julian, who's also here, who's the team lead, can talk about that. But yes, we do have an implementation.
Okay, thanks. Also, do you have test cases? That's my last question mark here.
Yeah, Julian, you can take that one. Okay, perhaps the connection doesn't work. Yeah, I'm pretty sure we do have test cases, but I'm not familiar with the code base off the top of my head right now.
Let me just add a check mark here. We can figure out details later. Let's quickly finish this round with mass. From what I understand, this does not require a hard fork. Correct, Isaac?
Correct.
And this also does not break Nakamoto consensus.
Correct.
You have specified this with the working group for Ethereum Classic, and you also already planned a transition. You already have a block number, or what was it you proposed in this? As I saw the pull request, you added a block number. This is
yeah, we have a tentative block number proposed.
Okay.
And, I've just pushed that to the pull request to try to meet spec, but as we've been working through our tests, we've pushed back that number since the spec was drafted.
Okay. And yes, obviously you have the implementation. Do you have test cases?
We have test cases for the Corgeth client, and we have those scenarios as programs. We also have the unit and integration tests at the code level. What we don't have are tests that could be sort of easily plugged into or harnessed by arbitrary clients. There hasn't been a need for that yet because there are no other clients that that are working towards implementing it, as far as I know, right at this point. But it sounds like Besu is maybe on the road to doing that, and so pulling together some canonical test data and instructions for running, or some kind of a simple test harness could be easily in the roadmap for like next week, if that's something that Besu feels like they'd like to have.
Okay. Okay, then thank you, Isaac. I would like to open up the discussion. Does anyone have any comments on these 5 proposals, or on the smart tracks specifically, or on the process going forward?
I think that it would be great to add to this matrix some other properties of the proposal, such as if they are subjective or they are objective, which is very important to prevent forks, accidental forks on the network.
Would that potentially fall under the no fork column? Maybe that could be renamed to be more clear, if so.
That was a completely different property. This is more about if there is a consensus, a real consensus on the network, or if nodes can have a different view of the state of the network based on these new methods of protection. So there are some proposals which are clearly subjective, like Pirlguard, and some proposals which are objective, like ours, and probably some other.
Yeah, checkpointing is also objective. Yeah, I think that would make sense as a criteria.
I think what Isaac was getting at was that implementation of the non-subjective ones requires a hard fork. So they're sort of the same thing.
Yeah, I'm just looking at this first column, no fork. So to me, I read that as if it breaks objective consensus, then it requires a fork. And if it doesn't break objective consensus, which is to say it's subjective, then it doesn't require a fork. But if there's if you have a different reading, I'd love to hear it, or hear how your understanding of objective and subjective is different than that.
Okay, I will think more about it, and I will post a message. Thanks.
Okay.
Okay, I will just take notes that we discuss subjectivity column for the smart tricks. What is the sentiment on this call? Is there anyone saying that some proposals are like not realistic to implement on Classic, or is there anyone championing for pushing forward a certain proposal? So maybe we can start talking the proposals now.
Maybe I can jump in with. I've been working on MES, and especially in the context of these other proposals, which I think are exciting, and I have to give my tip my hat to all of them, because they've all been worthy enough to be up for consideration. And one of the things that I like about MES, and I think I have to say I'm its champion, is that, and hopefully not alone though in being the champion, is that I like that it has a relatively light touch with what I see as a big lever for that touch. So this is a feature that we can add and then keep a conversation open as we observe, monitor, and continue to improve it, or continue to work on other solutions if we feel like we can see a better way even forwards later. MES doesn't close any doors for us down the road. And that was one of the core priorities, is to not close doors, and right along with another priority of trying to do the least harm and the least amount of risk to the network, so that that's kind of what I think about it being hopefully a light touch, but strong solution.
And this was developed with the help of ChainSafe and Open Relay, right?
Yes. Yeah.
Are you submitting this as an EIP also upstream?
I have not submitted it as an EIP or EBP yet. I figured one thing at a time. But yeah, I think it would be worth at least documenting upstream. At this point, I think for in terms of submitting it upstream, it may be worth doing from a documentation standpoint. I don't see Maya. I don't see a huge amount of value for them because their biggest risk is collusion, as opposed to an aggressive dominator attack, like a 51% attack. So I'm not sure that this is a solution for a problem that they have right now. But again, for documentation's sake, it might be worth it.
Yeah, I mean, it is a solution to a problem that blockchains have, and
Yeah.
lots of projects feed off of that. So if it was accepted as an EIP, then it would be easier to get it in a base. So it would be helpful in getting it into other clients like Multigeth or anything else that's trying to be compliant with the ETH main chain.
Okay. Yeah. Yeah. Yeah, it definitely gives a greater scope to it, and visibility, and hopefully a whole bunch more eyes too. So yeah, I think that's very worth keeping on the docket.
Yeah, I don't think it affects ETC either way. I think we should move ahead with it. I'm just saying, in general, I think you should also look to get it more broadly adopted.
Cool. Cool.
Is this something? I have a question. Is this something we can use as a temporary, like training wheels for Ethereum Classic, and that can be turned off in future once Ethereum Classic is more stable, or is this a permanent solution?
Yeah, that's I guess what I was trying to say with the light touch idea, and it is removable. Yeah, we can pull it out at any time.
Okay, another question. In case we have two clients on the network, let's say Coregas and Besu, and the majority of the network, especially mining pools, use only Coregas, would it be sufficient to only activate it on Coregas and see that Besu might resolve to an attacker chain temporarily, but in the long run reorganize back to the correct, the honest chain, which will be heavier if miners have MES implemented? Is this an assumption that's correct, or how do you see this?
Yeah, I think if I understand correctly, I think that is correct. It's obviously not ideal to have clients that don't have it on the network, but from the network's perspective, if the majority of honest miners do have it, then the network is safer than otherwise. Yeah.
Do you guys know if there's any percentage of Coregeth nodes that are live that have already implemented it or have some form of it implemented?
Do you mean on the mainnet?
Yeah.
I haven't been watching the statistics on mainnet. If that were the case, it would they would either be clients that were built from the source at the PR that we have up now, or they would be implementations that aren't ours.
Thanks.
Isaac, you have a test net or a simulation running. Would it be feasible to maybe test this out on Mordor?
Yeah, it would be completely feasible to test out on Mordor, and as it is right now, the PR has a block number that activates on Mordor like a week ago. So if you do upgrade your Korgoth clients, at least on Mordor, they will include the feature by default. So you can start testing. And it should be interesting to test with the pretty low hash rate on Mordor usually. So it'd be interesting to see what happens.
Yeah, that's what I'm trying to say. So we could just put out one mining node with this feature on Mordor and try to attack it.
Yeah. Yeah. And then the question to the simulation is our team has had a ad hoc testnet called messnet, which has had 149 nodes running for a week and a half now. And we've been running tests on that too.
And also, it's a command line flag, right, Isaac? If it can be turned off and on, so you wouldn't even be able to tell if other nodes are or are not running it. Is that correct?
At least the implementation so far has a command line flag, which you can use to override the feature. Which that was a pattern introduced upstream at Go Ethereum with Constantinople and Istanbul forks, where they included a flag that you could override the fork in that case if things didn't turn out the way you wanted, or you wanted to voice your opinion otherwise, you could do that. So we use that pattern. Although this isn't a hard fork, it just is a command line flag that you can use to turn it on or off by setting a number for its activation either very far into the future or any time in the history. It also includes an RPC command, admin _ ECBP1100, and that accepts a Boolean. So if you forget to use the command line flag, you can use geth attach and turn it on and off.
Okay.
And sorry, the other point is that because it's not a hard fork, whatever activation number you choose or the activation default number that's included with the default configurations, those don't show up in the fork ID protocol. So your nodes won't, if there are two nodes, one has it on, one has it off, they won't look at each other any differently in the context of the ETH6465 protocol.
Okay, thank you, Isaac. I don't know how to move on. I would suggest that we just try out to cut a release with a Mordor block and try to upgrade one miner on Mordor and see how it turns off, unless someone strongly disagrees that we should not have this.
Yeah.
Does anyone disagree activating a mining node with mass protection on Mordor? So the important part here would be that we kind of coordinate on the block number. So maybe, I don't know, do you have a proposal that's maybe not a block number in the past?
I don't have one on the top of my head, but would be happy to entertain them and to pretty much accept anything if the community is interested in that. Worth noting that if you go to Korgoth right now and look at the releases page, you'll see a pre-release published last week that actually does include activation for Mordor. So you can use that one, but it's also worth noting that being a developmental release and a pre-release, it was a beta release candidate for the clients that we tested on the messnet, and as such, it uses slightly different parameters and algorithm than are currently spec'd and are currently in the working branch. So just be advised that if we do want to pick a new activation number and make a bigger effort to roll out on Mordor, then there would be value in doing that, because we'd be able to test the latest implementation too.
Okay, let's do it. I don't know how consensus is required for this ECBP. Do ECBPs go into final or into active? I mean, because this is a feature that can be turned on and off, I would propose that we turn it to active at some point. What do you think?
Yeah, that sounds descriptive.
So let's use the final spec of this ECBP, put it in active only with the Mordor block number, and we can make a decision on mainnet later, maybe. Does anyone disagree with such a course of action? Okay, then unless someone has a comment on that, I would move on to the other proposals. I want to start on top of the list. I want to talk about Pirlguard again because I keep getting asked to add this on the agenda. Is anyone here willing to speak in favor of Pirlguard? Or let me ask a different question. Does Pirlguard make any sense on nodes that already have MES activated?
I would say it doesn't make sense if the nodes have MES activated. And MES wouldn't make sense on nodes that have Pirlguard activated.
Okay, another question. How does the network look like if some nodes have Pirlguard and some nodes have MES? This would be a mess, I guess.
No, they would eventually all resolve to the right network.
Sorry, say this again, please.
The networks would eventually resolve to the right chain. Either way, whether MES protects against the attack or whether it makes it all the way to Pirlguard. They're just redundant solutions. There isn't a situation where an attack would happen and then the two chains would end up resolving on different chains.
Okay, I see.
But if no one feels strongly about Pirlguard, then MES works just as well.
Okay. Then I would skip discussing Pirlguard, and I would also skip Veriblock because Veriblock will be having a presentation next week. Is this correct, Kevin?
That's correct.
So we will discuss Veriblock maybe after this presentation.
I haven't seen the MES crowdcast. I would like to, but I have a question for the MES representation. Is how would the network behave in case of a pause in the network? Let's say there is some issue and the network has to be paused for some time. Then how that the network reconnects if it's going to apply punishment to different forks?
Yeah, good question. I think it would depend on the nature of the pause. For the most part, at the implementation as is, from the algorithm's perspective, if the pause takes the shape of a long time between blocks, for example, and assuming those blocks are more or less accurately timestamped, then it would be pretty much the same. So because the algorithm uses the current local head against the proposed common ancestor as the domain for the function. So a long pause means a greater penalty. In the case of nodes going offline or Australia going off the internet, the core Geth implementation has features which are designed to be safety mechanisms to mitigate, in particular, eclipse scenarios. And so if a node or set of nodes sees either a drastic decrease in peers, or if they see their head become stale for just about 400 seconds, 390 seconds, then they'll deactivate the feature, in which case they would accept the heaviest chain available to them at that point. Does that answer the question?
Yes, I will look deeper into the presentation. Thanks very much.
Mm-hmm.
So it would essentially resolve itself.
Yes. Yeah. Resolution. Resolutions like to happen. You hope that, and then Cody has pointed this out in the discussion too, that you hope that resolution is working in the way that it's intended to, and that you're resolving to the chain that you actually want to resolve to. In the case that the network is paused or some subset of the nodes are paused relative to the network, in a malicious context, then that isn't always so clear because, for example, if the bad guy pumps the difficulty of the honest network to the level where honest nodes aren't able to keep up to an extreme level, then they would be vulnerable and let their guard down, more or less thinking that they had something terrible had happened. They'd gone off the internet because we just weren't able to create a block for so long. It's a very far edge case at this point. I took Cody's first concern. I don't know if you've seen this, Cody, but he raised a great point that originally I had that what I called like a staleness check safety delay. Average block time is 13 seconds, so I used 10 times 13 seconds as the staleness check. And if the node fails that interval, then it would disable mess. But I had done that against statistics over the last 2 million blocks, which Cody made the great point have been boring blocks. So looking at historical blocks, those can be longer when network hash rate is more volatile. So instead of 10 times 13 seconds, I've changed it to use 30 times 13 seconds, and hopefully that's long enough. And I don't think, if anybody feels strongly, I don't think it would really hurt to push that even up to 3 times that, or 5 times or 10 times that, if you feel strongly about it. The impact is basically just a convenience level impact for nodes that find themselves in precarious situations. So hopefully it's in the context of an edge case anyways.
Thanks, Isaac.
Hey, Isaac, do you know, like, a ballpark how long it would take for those other nodes to resolve themselves with the mesh nodes?
Yeah. It depends on what they've been doing. These offshoot subset. If the offshoot subset has been eclipsed attacked by let's say a relatively weak attack, where the bad guy isn't mining and feeding them a whole bunch of blocks, or gives up his attack in a relatively short time frame, then their resolution to the honest network would be quite swift, because the honest network's total difficulty will continue to grow, and their offshoot rogue network won't be growing at nearly that rate. And so they'll resolve. If the bad guy is maintaining some level of a minimum difficulty of a chain that he's feeding them, specifically like about 3% at least of the honest network's hash rate. If he does that, or if the nodes naturally, again, if Australia falls off the map, if they continue a chain that has anywhere near comparable difficulty with the mainnet, then their resolution will take longer. But supposing that the chains, the honest chain and the offshoot chain, don't have exactly the same amount of hash power on them, then they will resolve eventually. It's just a matter of time, and that time is governed by the hash power and thus the relative difficulty imbalance.
Awesome. Thanks.
Okay, thank you. We are 1 hour into this call. Do we want to continue discussing the remaining proposals?
I'm open to it. I don't know about others though.
Does anyone have any strong feelings, champion in favor of merged mining or checkpointing or opposing these proposals? So that gets us discussion started.
Yeah, I would champion for checkpointing, perhaps not necessarily against the MES proposal, but perhaps additionally as well.
Would checkpointing require a hard fork?
Yeah, so the easy answer is yes. So the easy way to do it is with a hard fork. But as I mentioned before, I am pretty sure this can also happen with a soft fork, although we haven't analyzed it, but though we do mention it in the ECIP. But what we talk about in the ECIP for the Federation case is to do it with a hard fork.
How would those, do you have any idea how those validators would be chosen?
Yeah, perhaps my personal idea would be that there are, I guess, entities or people inside this network that are already trusted and like stakeholders that people recognize, perhaps developers of current node implementations or other stakeholders in the network. And I would expect the community to come together and fork like a federation in this way. That's like perhaps non-controversial. But if this is not possible, then we also offer this decentralized option of doing this checkpointing using Bitcoin. So in that case, there's no federation that needs to be constructed.
And as far as validators go, they'd have to be fairly competent with running a validator node, right?
Yeah, I guess so. So you need to have you need to be responsible to run your node and your like whole application that does the voting and so on. But there's some tolerance. So if you like, the tolerance is half. So if the majority like is online and is honest and votes, then it's all fine. So even if we get some people in who are not so qualified in running their nodes, it's not an immense problem, but I think we can safely make the assumption that we can pick people who are technically inclined and can do that.
Cool, thanks.
So we're talking about hard forks. Something that I've completely overlooked with 1099 or any hard fork in general at the moment is that much of the ecosystem is running open Ethereum nodes and relying on the Trace API. So forking away from open Ethereum at the moment is problematic until we have either the ecosystem ports over or we port that functionality over to other clients. So just something to keep in mind in terms of hard forks.
All right, thank you.
Just one comment on OpenMuseum. This client has been kind of dead for a while, and forking away from OpenMuseum is probably our smallest issue right now. But it looks like we have to implement OpenMuseum features in the other clients.
Yeah, certainly helps ease the transition over.
Yeah, but this transition has to happen anyways. If we fork or not, people have to stop using this client.
All right, so if we don't have any more remarks regarding checkpointing, I would like to go back to the question that I made earlier about what the question of breaking Nakamoto consensus means. I mean, if that's all right, you can like schedule it however you want. But I think this needs to be answered, because if we don't have that, then we don't know how to answer this question for any proposal.
I can give it a try. So Nakamoto consensus basically means one CPU, one vote. This was the vision of Bitcoin, and it means that the chain should always resolve to the heaviest chain. And however, for Ethereum Classic, this also means with a low hash rate, you are kind of vulnerable for 51% attacks. And you can classify the proposals into groups of the ones that kind of try to honor Nakamoto consensus by giving at least honest miners the chance to vote on the best chain head, but still having proposals that exclude privately mined chains. So I mean, it's a I don't know where to draw the line, but technically all these proposals break Nakamoto consensus. So yeah, I don't know. What's your thought on that?
Right, that's exactly what I would get to. So yeah, I think there's two things we can rank these proposals on. One of them is the thing you said, which basically, well, as you said, all of them break because we need to change the protocol. Like there's no escaping that. And if you change the protocol, then you don't have the protocol, this Nakamoto protocol. So perhaps I think a fairer question would be, because what you would like to say, and I appreciate that you want to say this, that we maintain a similar rule in the same spirit, but only honoring like the honest miners. I think a fairer thing to, as an evaluation, to say would be to focus on the properties that we want the chain to have, which is we want the chain to have persistence and we want the chain to have liveness. And with Nakamoto consensus under honest majority, you have that. But perhaps if we make an alternative protocol that also has these things, then that's all right as well. And since we are not following Nakamoto consensus anymore, after some of one of these changes gets incorporated, I think it would be best to rank regarding these two properties. So persistence and liveness. And to my eye, at best, most proposals here, other than checkpointing, and they offer persistence. So the protection that we get from 51% attacks, it's as they're not able to reorg the chain very deeply, and that's fair. But liveness is a thing that's not so much discussed, right? So if you have an adversarial miner that just plays by the rules and generates empty blocks, if they have enough hash power, then you will not have liveness. So you may have empty blocks, you may have active censorship, and so on. So I think these two as criteria make more sense. And with regards to checkpointing is, I think, the only proposal that achieves both, and probably so. So there's a paper about checkpointing, and in which both properties are proven under the Bitcoin backbone model. So I think as a comparison, it would make sense to rank them with regards to these two instead of if they change the protocol, because they all change the protocol.
Does MES change the protocol?
Yeah, I would raise my hand to say that at least to offer an alternative opinion or an alternative understanding of maybe what we're talking about when we talk about the protocol. In my opinion, the subjective approaches don't tamper or change any part of the existing protocol. In my opinion, right now, miners mine on top of whatever blocks they want. And usually they mine on top of the heaviest block that they can find. And they do that because they think that that's going to be the most profitable for them. But under the existing protocol, miners can mine on any blocks that they want. So MES offers them a way to mine on top of blocks that without MES, they would maybe mine on top of without knowing the provenance of that or being able to form an opinion about the provenance of that chain. So I think my point is that this just allows miners to pick and choose which blocks they mine on top of, which is a property that the chain already has.
I'll just back Isaac up on that one in saying that the subjective approaches don't change block validation in any way whatsoever. So this is why they don't require a hard fork. So the rules of the protocol don't change at all. That's sort of a key aspect. That would apply to MES and Pirlguard.
Yeah, and not just block validation, but block production, which is block sealing. So nothing there changes either. And I think I would also want to point to your idea of liveness, which I think I'm associating with. Correct me if I'm off base here, but I would associate that with what in other contexts maybe is considered availability in terms of like a broader database context. So, like, are you able to make the transaction that you want to make with some store? And it seems almost like a straw man to say that checkpointing fixes availability, and it fixes availability because you trust the people to accept those transactions. Or you can say you incentivize the people to accept the transactions. And it seems like more or less those same properties exist on the chain as they are now. I mean, we incentivize miners to accept and process transactions. And so on a checkpointing system where the miners maybe are trusted entities, they're incentivized still. And maybe they're incentivized in other ways. Maybe they don't want to lose their reputation, or they don't want to lose their opportunity to earn the reward. But I'm not sure I see exactly how fundamentally the characteristic has changed.
Yeah, I can answer both these things. So with regards to the protocol, you said that miners right now can pick and choose what they mine on. I understand where you're coming from and the kind of thinking behind this, but like if you see formal definitions of the Nakamoto protocol, you will see that in order to define honest and adversarial nodes, the way you do it is that the honest nodes need to have a specific rule of choosing, and this is exactly what makes them honest. So I mean, if we don't make this, if we don't have this, then we really can talk about like adversaries. So the exact definition of an adversary is someone who does something other than that. And right now the miners could choose to do something other than that, but in that case they would be adversarial. There's no way for us to know that they're doing it with good intention. So that's the first thing. And the second thing is with regards to liveness. I understand there's a bit of confusion around I guess the checkpointing protocol. So there's no trusted miners. There's a federation that may make it centralized, but you can also do it with timestamping on Bitcoin. The liveness doesn't come from the fact that any of the miners are trusted. The liveness comes from the following fact. So imagine you have the honest miners and some adversary who overpowers them. And you can imagine that in this case, in the long run, the adversary will just mine the longer chain. So what checkpointing does is it says, every k blocks, we insert some randomness in the kth block so that basically the adversary cannot just keep using this very long chain he had started making at the beginning. So you actually make them start mining at that kth block, and that actually gives a benefit to the honest miners to actually and allows them in the long run to win at this mining game. So this basically tells you that at some interval you will have a block from an honest miner, and this is how you get liveness. This has nothing to do with centralization or federation. In fact, you don't need centralization to do that, and I don't see how any of the other proposals solves that, because again, an adversarial miner that wants to harm liveness can just mine empty blocks, and there's no way around that.
Interesting. Thank you. Yeah. Thanks for your response.
The cost of maintaining such an attack would not be overly feasible in the long run. Like, you'd have to maintain that for quite some time.
Right, but
Like,
yeah, I mean,
indefinitely.
yeah, I
It'd be
understand.
insane.
I understand that, and the cost, I guess, would be high, but you should also consider that someone may have other economic incentives that are exogenous to the system. So if, for example, I want to bank on Ethereum Classic being harmed by Liveness, then I can bet against it on the market, then mount this attack for as long as I want until the market reacts, and then make my money that way, and perhaps I can make my money back. So we can...
but the market will react very slowly because no one will be able to transact moving coins to exchanges.
Yeah, I guess
you need
so.
Liveness for the market to react.
That's a good point. But I mean, there are certain things you can do that are exogenous to the system that we should also consider, because if we only consider what is lost by not mining honestly and so on, this is a very narrow view of the world, and attacks can be complex and involve other external systems that perhaps we cannot foresee. So this is why I think we should lean more towards or like theoretically at least proven or reviewed options that have clear objectives and prove clear things. I'm mentioning this like in general, not specifically regarding to chatting about checkpointing. This is like an observation I have reading all the comments on the ECIPs and I guess on other ICIPs as well.
Shall we continue?
Did we lose Zachary?
No, sorry, I was muted. Yeah, that's it. I don't have any strong opinion on this right now, but I want to give a final chance to discuss checkpointing and merged mining. If anyone has any strong opinion in favor of this proposal or against it, can speak now. Other than that, we are nearing the end of this conversation today. So yeah, let's use the last minutes to discuss these proposals further.
Sorry, go ahead, please.
As something I'd bring up against merge mining is being the smaller network in that scenario tends to not favor well economically. You end up with a lot of miners that have zero interest in the network getting most of the new supply and just dumping. That's not really a technical criticism, but certainly an economic one.
Okay, to answer to that, the merge miners, the Bitcoin miners will be only providing visibility proofs. So I'm not sure since the original proposal is to derive to separate some small portion of the subsidy to the Bitcoin miners, then I don't see any problem with that. There is a cap on the amount of power and that the Bitcoin miners would have. So if I understood correctly, I don't see a problem there.
All right, cool. I'll look into it some more.
I just want to bring to the table the thing that if we go with a Pirlguard or MES, then we should consider isolation attack in much more detail. So a target DOS attack against a node can, block a node, for instance, giving, too many transactions to evaluate, or submitting blocks that are too expensive, that take a lot of time to evaluate. So we open also the door to a lot of attacks that until this point were not feasible. And we can get a node to be isolated from the network for a period of time.
Yes, I would chime in there. I think you're absolutely right. And we are running tests with that in mind. And we're aware that that is one of the vulnerabilities that this kind of subjectivity exacerbates. Although I think it's worth mentioning that these issues are issues that nodes, as is right now, are at risk of currently, although for example, the length of that isolation, the duration of it may be exacerbated by mess, but it's not an original issue.
Do we have any figures on how much overhead mess adds? I would assume it's fairly minimal, but I don't know exactly.
Yeah, I can't give you any specific benchmarks. I haven't done specific benchmarking for the very few places in code that are added. My guess is it's no different than logic changes that have been made before around this kind of thing, like changes to difficulty and stuff like that.
Oh, yeah, that's what I'd assume. It's minimal enough to be similar like any other conditional hard fork type of scenario.
Yeah, it does add an extra condition, but the amount and scope through which Geth, at least the implementation that Core Geth uses, is refactored. I think that it's the code moves around enough that changes of this scale are very common, and so that's why I haven't done benchmarking, because if loops and if loops get added all the time, and this only adds a couple of them.
I only brought it up because of the question.
Yeah. But it is worth considering. Absolutely.
Does anybody have any opinion on what happens to the network positively or negatively if we end up with multiple implementations of these proposals?
Do you mean that if there's checkpointing and mess, or checkpointing and something else,
like
or
checkpointing and mess and Pirlguard, and say Veriblock comes in also and they want to just, go for it if it doesn't require a hard fork? Will that negatively affect the network? I mean, I assume it adds a lot more complexity.
Would create forks on the network, almost for sure.
Yeah. It sounds very complex.
Yeah. And I would stress that too, even, under, in my opinion, like if you put Pirlguard and mess on the network with different parameters, you're not necessarily going to see forks. Of course, you're not going to see a fork if nobody's attacking. But if somebody does attack and they know the difference, they will be able to pick at that difference. And there would be an option or at least an opportunity to partition the network for some amount of time.
Right, but on that note, there is a difference between mess and Pirlguard and checkpointing and merge mining. So if 51% of the nodes never get mess implemented on them, then the network's still not safe.
Right.
So, and we're still the minority chain in the eth-hash world, and that's not really changing. So if mess is accepted as a best practice, then it still might make sense to continue looking at checkpointing and merge mining.
I kind of want to hop from where what you said, Cody, because Yeah, because when I think about from a service provider's perspective, like you would have to make sure that every node is using it, especially when we're so vulnerable. And the cool thing about checkpointing is I feel like you have a little bit more, like when you think about a service provider perspective, let's say I'm a major exchange. If I know there's a checkpointing system on, I know that there's a more deterministic and predictable amount of blocks or that I know are safe. And with mess, like I would say when you have mess, let's say we implemented mess, what would you tell a service provider as far as confirmations? Of course, you don't want to recommend 10 blocks or 100 blocks or even 20,000 blocks, whatever. But what would you suspect to be a reasonable confirmation time from an exchange's perspective? There's mess. Is there an algorithm for that? Because I know if we had checkpointing, you could have something a little bit more deterministic. And especially when it comes to if mess isn't implemented on all the nodes, and who knows if an attacker is just going to mess with us again before we even try to solidify all these changes. That would be some of my concerns. So, and another question I would say, is it possible that mess and checkpointing could coexist?
Sorry, can you repeat the question? Did you ask if there's any possibility for checkpointing and mess to coexist?
Yeah, if mess or checkpointing can coexist, and then also like what Cody mentioned about if most of the nodes aren't using mess, the network is still at risk. And even if a 51% attack happens while nodes are trying to updating, we are still at risk. So, and the cool thing about checkpointing is you have a little bit more deterministic predictability about when a transaction is final. And that's one of the trade-offs. Of course, all these break down the mode of consensus, but yeah, like can they coexist?
Right. I think they can. So with checkpointing as something that I think checkpointing works well with other proposals because you can easily say that whatever result the other thing has, checkpointing has the most authority. So if you, for example, use some other rule and this rule determines that some block perhaps that it will not adopt some block in its main chain, but then this block or some child block of it gets checkpointed, then you basically believe the checkpointing instead. So if you do it in this way, then it can work with most other proposals, as long as the blocks are kept and not discarded, even if they don't go on the main chain. But this is an implementation detail. The answer is yes.
In the case of merge mining, visibility proofs together with mess, the answer is also yes. And it's interesting because you get a kind of absolute clock to measure if a fork is new or old, where instead of using your subjectivity of your local clock, you are using the Bitcoin timestamping as a global clock. So in the case of visibility proofs, you can also combine it with mess and improve mess in that regard.
And from a service provider's perspective, like if you're relying on, because I trust Bitcoin network security. So let's say a major exchange uses like 6 confirmations for Bitcoin or something, but they can use the same predictability of, hey, this is when a transaction is safe on ETC if it was relying on Bitcoin's proof of work, or even if it had if we had a checkpointing side chain, we would know like, hey, this chain, this many of blocks is absolutely assured, or at least a lot more deterministic than than mess.
So then I guess the question is, how long do we need the checkpointing for? When do we turn it off? Is this when we move to the reduced DAG, or whenever we switch to SHA-3, or when's the cutoff point for having to have an external system other than just mess?
When we inherit all the F miners, what do you think?
Right, I would tend to agree.
That's probably not going to happen, though.
Yeah.
We're changing the algorithm. So
Yeah, I mean, you need to have an indication that you have a healthy miner population. If you look at Bitcoin Cash, it's so many years have passed and they haven't been able to accomplish that. So there's still a tenth or a hundredth of Bitcoin's mining power. So it's if
We're about the same with Ethereum right now.
right, exactly. So this establishing a healthy miner population needs to be solved separately, and once it's solved, of course, checkpointing can go down. And to go down, it doesn't actually need another hard fork, so that's, I guess, also a plus. But this is a separate problem which doesn't really have to do with checkpointing.
And I know from the and then you think about, like, I would think it would be in the like when we reduce the DAG too, it's going to be in the interest for rental hashing platforms, I think, to support, let's just call it ETC hashment, so, when it does the DAG diffusal. And I know, like, the buzz on social media between miners is like, hey, when Ethereum goes to the 4 gigabyte DAG, what am I going to do with my rigs? I'll attach to NiceHash. And there's not too many options, maybe like Ravencoin or Ubiq and some other ones, but Ethereum Classic has arguably more profitability. And when those rental platforms come back on, now we have all this cheap hash. And we're just assuming that our hash rate is going to increase when we diffuse the DAG. It might for a period of time, but like you said, Bitcoin Cash is in its current position being a minority chain, and we of course are a minority chain. And maybe the long-term solution is when we try to become a majority chain with a different proof of work algorithm entirely. But it also puts us at, but like in because I don't trust cheap hardware, so we're gonna adopt mesh. Not all the nodes are updated. Okay, we got all these cheap mining farms that come on, and I know if there's checkpointing, we're rest assured. Yes, we have a predictable confirmation time, and we could tell users, exchanges, hey, there's checkpointing enabled here. This is activated, or that maybe it's 100 blocks, 1,000 blocks, whatever it is. But we're still vulnerable now, and I'm thinking like short-term security. I would hate to see someone try to mess with us again while we're trying to implement mesh or a DAG diffusal. I know I know in general it's an uncomfortable timeline for us, but it's just some thoughts.
I have a question. It's a little bit.
I have a note. We are 92 minutes in this call, and I would like to maybe propose that we close the official part of this call and maybe move.
Oh, you cut out.
I'm sorry, my Discord just crashed in the middle of the sentence. Let me rephrase this. We are 92 minutes in this call, and I would propose that we continue this discussion either offline or here on this call, but close the formal part of this call and continue the discussion on a later point. If you want to stay on and continue discussing, just feel free to do so. But I would like to encourage us to have the more coordinated part of this call on a later date continued. What do you think?
Sure. I'm happy to stay on if anyone else wants to continue the discussion.
And
I also like to.
go ahead.
No, I would also stay to have a question for you.
Awesome. And so we would be deciding next time about the last call proposals, or as far as these proposals in their stages.
Oh, that's a very good question. So the process is the following: unless someone brings up anything that is really critical or blocking these proposals, they will move to accept it. Here is for 1099, this will move to accept it in the way we discussed it today, unless someone brings up concerns till the review period ends. I don't have this proposal open. When does this review period end? 99. I think it's another week.
I think so also.
The pull request is still open. Changed review period, and yes, it's next Friday. So there are another 7 days to bring up any concerns with these proposals. If this does not happen till next Friday, this will automatically move to accepted. This is basically what last call does. And the other proposal, the Keccak proposal, it has a different. It has a longer last call review period, and this ends on in 2 weeks and 14 days. And for this proposal, it technically would also move to accept it in 2 weeks, but we have another call with this proposal next Friday at the same time. So if you want to have, if you have any concerns on 1099, then bring it up on GitHub, on Discord, make noise. If you have concerns on 1049, then best is to join the call next week.
Awesome.
So that's it from my side. Thank you, everyone. And if you want to stay on this call and discuss further, I will be available for another half an hour, but I will want to just close the formal part of this thing, Okay?